This video will demonstrate how using mathematical software that features the ability to vary parameters in a family of curves can help students develop their understanding of functions and graphs. Here, you will see a teacher using graphing software to investigate how varying b and c affects the graph of y equal to x squared plus bx plus c.
Give us some sliders as well. Usual parabola shape. I'm going to move the slider for c, the constant at the end, and let's see what happens to the graph. So what's happening with the shape of the graph there?
The y-intercept is changing.
By how much?
By how much you're changing the slider for c.
So let's fix that constant c at, say, 4. What's going to happen if I change the slider b? What's going to happen to the shape of the graph now?
No matter if it's negative or positive.
It would be like a stretch like that, I think.
So it will shift that way at a rate of, well, if we add 2x.
Then it will shift essentially one to the left and one down.
So predictions. What's going to happen? What's going to stay the same? What's going to be different?
Would it be a stretch parallel to the x-axis by 1 over b?
Okay, so possibly a stretch parallel to the y-axis.
If we look at the y-intercept, then it will remain unchanged because we're letting x equal 0. So even if you have b as a number greater than 1, then it'll still be 0 plus 4. So the y-intercept will remain at 4.
Okay, good.
Would it be some sort of translation diagonally, like a vector of minus b over 2 minus b over 2, if you change b?
Well, let's see if you're right then. So it's obviously still going through 4 on the y-axis. Is that doing the translation you said it was going to do?
Not quite. Not quite.
So let's actually
This.
animate that so we can keep that going.
Yeah.
How could we analyse that in a bit more detail? By using the graph perhaps rather than the algebra?
We could plot the points of the minimum point of the graph.
So that's given us our minimum point. From what you've seen already, what shape are you expecting to see?
Like an upside down parabola.
And there we are. Can we get the equation of that upside down parabola?
The y-intercept remains the same?
Yeah, so it's where the y-intercept, so it's that's minus 4, which isn't right. So that'd be minus 4. So is it like plus 8 afterwards?
No, you have to be negative though, because
Oh, because then that wouldn't equal 0 and those equal 2.
Okay, have we got the equation for that new parabola? Dan,
So is it y equals negative x squared plus 4?
how could you rearrange that to make it easier to say?
4 minus x squared.
Creating things on the fly, it's surprisingly easy once you've done it once or twice. You can work with the students a bit more and feed off them and develop what they're thinking as you're going along. Obviously you're trying to direct things. They will quite often do something that you hadn't planned for, you're not expecting, and I will most of the time go with it for a while and see where it ends up.
What was so useful in that activity about sliders, and when do you find yourself using sliders in graphs?
With the sliders, it allows you to change it as you want it without having to do it the old-fashioned way of redrawing a whole series of different graphs. You can just change the values and see the effect immediately. How did seeing the moving graph there, how did that help you?
You could see that the traced out path had an intercept of 4.
I could quite easily visualise the quadratic moving in a straight line, but the moment I'm trying to visualise it moving in a parabola, that was just too many numbers to have in my head at the same time.
Well, I think we're definitely very familiar with a shape like a parabola, but especially when it comes to more difficult functions, it really helps us visualize how the function works to actually see it being drawn out rather than just be given, this is the graph, that's how it always looks.
What level of confidence did you have to have before you felt comfortable doing that in front of students?
I suppose the nervousness is knowing what to do if it doesn't quite work as you expect it to. I think you just try again and see if you can work out why you've ended up in the situation you've got.